Right, so I've got this session running as nlam on workstation 2. If we do a whoami groups, we'll see that this user is a member of the built-in administrators group. So this user does have local admin privileges. But this process is running in a medium integrity level. If we open command prompt on the user's machine, whoami groups shows exactly the same thing. And if we try and do something that requires elevated privileges, like adding a user, it will fail with access denied, even though we're a local admin. So what you have to do is right-click and say run as administrator. And when you do that, you get the dreaded UAC prompt. There are a couple of different UAC configurations. This is just yes, no. You can have it so the user has to enter their credentials, but either way, the user has to explicitly give it permissions to run. And if we do whoami groups again, it now says we're in a high integrity session. And if we add the user, it now works. So a UAC bypass is not an elevation of privilege per se, because the user is a local admin. What we have to do is, from our beacon, is spawn a new beacon that is running in high integrity without prompting the user with the UAC prompt. That's why it's called a UAC bypass. Like Cobalt Strike has two main ways to do this. The first is with the elevate command, and with elevate, help elevate, you give it an exploit, which is these are the two that are built in, and a listener. So if we do elevate UAC token duplication bypass, tab, the tab works on these, so you can just do like UAC tab and tab complete for the listener, so TCP local. And this will automatically spawn a process in high integrity and inject a beacon payload in for the TCP listener. The other method is using the run as admin command. And it works in a similar way. We give it an exploit, but we can give it any arbitrary command and arguments that we want. So we're not limited to just spawning a beacon, we can run anything in high integrity. Run as admin to see the exploits. So let's host a payload for the TCP listener on the web server. I'll just call this one B. And let's cut that. And so we want to do run as admin. And let's do the UAC CMSD. And then paste this in. And hit go. If we check out the weblog, we see the get for B, and that's important because when you run these types of commands manually, the beacon won't automatically try and connect to the peer-to-peer beacon, so we have to do connect. Okay, and now we have two high integrity beacons running off this one. Now, not all UAC bypasses are created equal. So let's go to this beacon and let's try and do something that needs high privileges. So let's run Mimikatz logon passwords. And it works fine. We get a whole bunch of output. So that worked without issue. If we go down to this one, this is the one that we spawned with the token duplication bypass. And if we try and do logon passwords, we actually get access denied. And if we try and add a user, that's not how you do it at all. This one actually appeared to work. So, like, what gives? Well, if we switch back to this beacon, let's do execute assembly, C tools, seatbelt, seatbelt. And with seatbelt, you can give it specific things that you want to check for. So I'm just going to say token privileges. And you can see here that there are quite a few. Even though they are disabled, we have a lot of privileges available to us. If we do the same thing in this beacon, you can actually see that we have a fraction of what we have over here. Now we saw with adding the user, we still had permission to do that. But how do we go from this to this? Well, the easiest way is with another one of the elevate commands. And this is the elevate service. So we do elevate service XC. Since we still have permission to interact with the service control manager, we can spawn, use it to spawn processes via services. And so now if I run logon passwords from this beacon, it works completely fine. So remember that not all of the UAC bypasses are going to produce exactly the same results. They all work in different ways, they all have their own quirks. So make sure you research the bypass based on which one you're using so you understand any quirks or drawbacks that it might have.